Direct current, DC current.
Okay.
AC అంటే ఆర్డర్ వేసుకుని మనం వాడి
All of you listen. Some people are joining still. Okay, I'll start with the first unit about the circuits. Okay, that is the DC current. In the second unit, we will going to start with the AC current. Okay, so we will start with the DC. Total two types of currents are there. One is AC, another one is DC. DC stands for direct current. That means direct current in the sense here whatever the magnitude is there, the magnitude is constant magnitude. Suppose 220 is there. Suppose 220 voltage is there. That means 220 voltage is maintained constant. Suppose 10 amps is there. It is maintained constant. Okay. So it stands. That means irrespective of time, the magnitude means whatever the value is there, it is maintaining constant. That is called direct current. Okay. Some person is making lines. Okay, we will in the about AC we will see in the second unit. So before that, what are the things are there, we will just see in detail. Now come to the classification of materials. Okay, based on the conductivity. Conductivity means what? The flow of electrons. Okay, the flow of electrons. When the flow of electrons is there, that means conductivity will be there. If there is no flow, means there is no conductivity. Okay, so based on that, materials are classified into three types. That is conductor. Please mute yourself, some person.
బయటికి రావడం నీకు కూడా డిస్టర్బ్ కాదు.
Mute yourself. Okay, so we will see with the materials. So materials based on the conductivity, they are classified into three, that is conductors, semiconductors and insulators. So what is meant by conductors? Conductors means which they have plenty of free electrons. What it will do? It will conduct, it will pass. That means all these electrons, whatever the electrons are there, will align in one particular direction and it will flow. That means a closed path will be created when we give the supply to that element. Some disturbance is getting background. Please mute yourself, all of you. Okay, so based on the conductivity, that is conductors are classified because the conductors having a plenty of free electrons. So like copper, aluminum, which has so many free electrons. So conductivity, the name itself indicates it will conduct. That means if we apply for the copper, because we know that in the wire, if we take copper wire, what happens if we connect it to the bulb? Automatically when the source is given, the bulb will glow. That means copper is having the free electrons. That means conductivity is taking place. Okay, likewise if you see semiconductors, have you observed or not? Semiconductors, the name itself is indicating that semi, that means it will allow in one direction, it will not allow in another direction. That means we know that when you apply AC source, what happens in AC? AC means alternating current. That means it is going to change in one cycle. So for every cycle it has two, that is two polarities. One is positive, another one is negative. So during positive, what happens is it will allow. During positive, it will allow. During negative, what happens is the resistance, whatever the resistance value will there, it will become more. So just like the examples are germanium and silicon, you can observe the diodes in the functions. You can observe some lights are flickering takes place. Why that flickering is taking place? During positive cycle, it is allowing the current. During negative cycle, what happens is means the resistance will become more. That means it is just like insulator. So it will not allow the current. So at that time, what happens is the bulb will not glow. So likewise, we will have the some applications. Now coming to the insulator part. What is meant by insulator? Insulator is nothing but which do not have any free electrons. Okay, that means it is not going to conduct. So some examples will be wood, rubber, etc. Like that. So many elements will be there. Okay, so this is all about the classification of materials. Now let us come to the concept of charge. Concept of charge. So what is meant by charge? So we know that matter. Okay, in matter, what it is mainly consisting of three particles, yes or no? So atom consisting of three particles. What are they are, some persons are joining very late, disturbing me. Santoshi, what happened? You raise your hand, is there any problem?
No, sir.
Okay. Okay, so let us see this atom consisting of three particles. They are protons, electrons, neutrons. We know that all these concepts already have completed in physics part. Just we are revising those points before going to our subject. Okay, so here what happens is protons consisting of positive charge and electrons consisting of negative charge and neutrons no charge. So atom basically it is a positive charge consisting of all these particles. Means what? Positive and negative, what happens? Going to cancel, yes or no? Positive charge is there, negative charge is there, so automatically electrically it is neutral. So what about that? How you say it is a positive charge, how you say it is a negative charge? Means, so by some means, by some external force or by some external energy, if you remove one electron or if you remove one proton, what happens? Some in that atom it is consisting of some charge, no? All these three particles are there. So what in that, if that all the three particles are there, if any of the particle is removed, if any of the particle is removed from that one, what happens? Automatically it will become some charge. Let it either be positive or either it may be negative. Likewise, it is consisting of some charge. So if by some means electron is removed, so in an atom it is consisting of three points, no? So I have removed that electron from that one. Automatically what happens? The neutron is no charge, no? So it is, only thing is electron is removed, means automatically it will become positive. So positive charge is going to be created in that one. Okay, likewise, if I remove that electron, or if by some means if I add some electrons into it, if extra electron is added to it, what happens? It will become negative charge. So that means we can say that the charge definition, charging is nothing but what? In your mobile also we are charging, yes or no? In mobile phone we are, what we are doing? We are charging that one, the charging the battery. That means we are sending some electrons. Okay, we are sending some electrons such that it is battery is charged up. Like that, if we addition, clearly we can define that the total addition of excess electrons in an atom. Okay, if we add excess electrons in an atom, that means it is nothing but a charge. Okay, so that is the definition you need to write. Now coming to the electromotive force, we will see with electromotive force. Is it clear? Now coming to the electromotive force. So charge is clear, everyone. So simply we have to say that the total addition of electrons, the total addition of electrons in an atom is known as charge. Charge is represented by Q and the units per charge is coulombs. Okay, already you know that. So again we have revised that one. Now coming to the electromotive force. What is meant by electromotive force? The name clearly indicating that it is force. Okay, force we are, and motion. Motive means what? Motion. And electro means electrons. Electrons in a motion. That means because of the force, some electrons are drifted in some direction, particular direction. So clearly we can say that here in a material, whatever the material is there, in a conductor, atoms are consisting, no, all these atoms are positive, negative, and electrons are there. Here you can see that two figures are given. In that you can see that these all, whatever the atoms are there, they are aligned in different direction. See the arrow mark direction, one side, other in right side, and one is in left side. But when you apply some force, to it, that means applying some force is nothing but by giving some external energy to it. Now what I am doing is I am applying the battery to it. Okay, if I apply some battery source to this one, what happens is automatically the battery is consisting of what? Battery is consisting of two polarities, that is positive and negative. So automatically whatever the electrons are there, they will align in one particular direction. Okay, the arrow mark is given now. The arrow mark, see that arrow mark, previous diagram, the first figure A, you can observe that the arrow mark is in random positions. I have taken some 6 particles, all are aligned in random position, but when I applied one source to it, they are aligned in one particular direction. You can observe that one. That means all the arrow marks are aligned. Aligned is nothing but directed. All these arrow mark directed towards the positive. That means these electrons are attracted. You know that all the electrons are attracted towards the positive terminal. Yes or no? So here what happens is, because of this one, because of that battery, an electrical effort required to drift the free electrons in one particular direction. Drifting means moving in one particular direction. Okay, moving in one particular direction is known as electromotive force. Whatever the force, whatever the energy we are giving, that we are calling it as electromotive force. Is it clear, everyone? An electrical effort required to drift the electrons, whatever the free electrons are there, they are moving in one particular direction. Okay, so that is the electron flow is in towards the positive. But conventionally the actually all the electrons, whatever the electrons are there, electrons are moving towards positive, but the direction of current, actually what is meant by current is nothing but the flow of free electrons. Whatever the electrons are there are moved in one particular direction. But the thing is, what we are doing is, conventionally, for the calculation point of view, for easy analysis purpose, what we are doing is we are considering the current direction as opposite to it. Okay, actually the direction of electrons is towards the positive, no, but the current direction, where we are taking, the current is coming from positive to negative. The current direction generally we follow positive to negative direction. You should follow this analysis, but the actual current is flowing from negative. Okay, all these electrons are moving, no, attracted towards positive, but conventional method only we are following. Okay, is it clear? Some persons are Now coming to current, what is meant by current? Just now we discussed, no, current is nothing but the flow of free electrons with respect to time only, no, the flow of the rate of flow of charges. What are the charges? Charge carriers, the electrons only, no. So the rate of flow of free charges, that is the electrons, is known as current. So that is with respect to time only, no. So that we just mathematically we can represent current I as I is equal to, I indicates for current. Okay, For charge, q it is indicated. So I is equal to dq by dt. Derivative why we have taken? Because the flow of electrons with respect to the time it changes. No? That is why dq by dt. With the help of supply, as the voltage is more means automatically the flow is fast. No, likewise. Now coming to electrical network. What is meant by network? Here electrical network is connection of more things. No. So here what is electrical network? Connecting combination of so many things. So all are related to electrical elements only. No. So likewise resistors, capacitors, inductors, and also it is consisting of some sources like voltage source, current source, etc. Okay. So it is a combination consisting of so many elements is together. We are calling it as electrical network. Okay. And what about the, so while electrical circuit is different. Circuit here it is indicated with current. No, you just change it. It is electrical. The arrow mark I am showing. No, that is electrical circuit. Here it is the electrical circuit. Circuit means what? Circuit means at least consisting of one closed path. Network means so many things are there. Okay, network means so many combinations are there. But the circuit is there. No, circuit means at least one closed path, then only we can say it as a circuit. Is it clear? Now coming to the electric potential. Just now we have finished with electromotive force. No, same likewise electromotive force, the electric potential also will be same. So other definition also we can write for electromotive force. Here electrical potential means what? Having some, okay, energy, like that. So what it will do? It is just like energy source. No, what it will do? It will, whatever the work is there, okay, it will do some work. Here previously we have taken that all the, whatever the charge carriers are there, they are aligned in one particular direction. No, so they are aligned in one particular direction and they are attracted towards the positive terminal, or whatever the electrons are there, those are attracted towards the positive terminal of the battery. Okay. So here what happens is, this electrical potential is nothing but some work is done. No, that means whatever the electrons are there, whatever the charge carriers are there, they are attracted towards the positive terminal, which is nothing but some work is done. Yes or no? They are moving. Moving is nothing but some work is done. That is nothing but potential, electrical potential. So we are bringing the unit to positive charge. V is equal to dw by dq. Okay, work done per in moving a point charge. dw by dq is nothing but work done in moving a point charge. Okay, then what is meant by potential difference? So already we have seen that emf, electromotive force, electrical potential. And then what about the potential difference? Potential difference will be between two bodies. In your you can see uh, in the plug point, you can see the socket, 2 points will be there. Yes or no? If you see one any cable, for that cable, okay, 2 pins will be there. One pin will be for positive or phase, another pin will be for negative. Okay, so you can see that two potential bodies, 2 pins will be there. That means there is some potential difference. If there is no potential difference, there is no closed path. Okay, so some potential difference must be there in order to close it. So 2 pins must be there, minimum 2 pins. Okay, minimum 2 pins must be there. The difference in two potential bodies is known as potential difference. That means you can see, you can observe that you can measure by using multimeter. You just place one multimeter in the socket. You can observe the voltage, like in our household it is 220 to 240 volts range you can observe. So that is the voltage. That means one is phase, another one is neutral. Phase is there, neutral is there, means one voltage is, that is 240 volts, another one is 0 volts. That is the difference. Potential difference means 240 minus 0, the voltage will be 240. Okay, and coming to electrical, one electron consisting of how many, okay, coulombs of charge? That is one electron negative charge. No, that is minus 1.602 into 10 to the power of minus 19 coulombs. Okay, so likewise we can get the how many electrons are there in 1 coulomb also we can calculate by taking the cross multiplication. If you do cross multiplication, you are going to get 1 coulomb consisting of how many electrons. You just do the cross multiplication, so you are going to get the number of electrons for 1 coulomb of charge. Okay, now coming to the types of elements. Okay, so coming to the types of elements, it is consisting of two elements. One is active, another one is passive. So what is meant by active? Clearly the name is indicating active. Active means which is delivering, okay, whatever the energy is delivering. Passive means which is receiving, okay, receiving energy. Active means sending energy or delivering energy. So we know that two sources are there. That means from the battery we can say that it is a voltage source, okay, and we can create the current source also. Okay, after having the battery we can create some current source and we can deliver to the required elements. Okay, so clearly we can say that voltage source or current source are the energy delivering elements. Okay, that is the examples. Voltage source and current source are the energy delivering element. So this is important question. Okay, they may ask. Till now all those things we have already discussed in the physics. Now the thing is, from here you are going into the subject part. Okay, types of elements. What are the different types of elements? They will ask like this. Okay, you have to say that there are two types of elements. One is active element, another one is passive element. Active elements means which are delivering energy delivering elements in the circuit. What are they? They are voltage source and current source. Now coming to passive elements. Passive, clearly we can say that passive means what? Passive means receiving element. Okay, the receiving element, energy will receive or absorb. Okay, they will consume that one. What are the consuming elements? Consuming means the resistor, okay, capacitor, okay, resistor, capacitor, inductor, not conductor, that is resistor, capacitor and conductor. RLC elements are there, no? Those RLC elements will are the passive elements. Now coming to the concept of Ohm's law. So till now it is clear. Participants, is it clear? Hello, anyone answer? Is it clear?
Yes, sir.
You can unmute yourself. Okay,
Yes, sir.
Yes, sir.
okay, okay,
Yes,
okay, okay,
sir.
okay. This is also very, 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 very important. Ohm's law. They are asking for either a 2 marks or 3 marks question. Okay. So Ohm's law. What is meant by Ohm's law? Ohm is a scientist. No, he conducted some experiments and finally he given that what happens to it. Okay. So let us take this one conductor. Okay, conductor, that is the resistor. Some resistance he has taken. So what he did, he conducted some experiments. So after the conduction of so many experiments, uh, he finally concluded that at constant temperature, okay, whatever that constant temperature, previously also we discussed, no, some voltage source we are giving. If we give some voltage source, what happens? Automatically all these electrons will align in one particular direction. That means all the electrons will attracted towards the positive terminal of the battery. So here also the same thing is going. That means here whatever the battery is there, which we can call it as a potential difference. The battery is nothing but it is having some potential difference, no, positive and negative. So some potential difference will be there. That voltage when we are applying to it, okay, at constant temperature, okay, at constant temperature, what happens is when you apply some potential to it, automatically the current will be flowing. Yes or no? When you give the potential difference or battery, the current will be flowing into it. Okay, so this is the statement you need to. This is a statement you need to write. At constant temperature, the current flowing in the conductor, whatever the current is there, that means mainly this current will be, how the current will be, the rate of flow will be depending upon, just now we discussed the rate of flow, where it will be depending, the rate of flow of current will be depending upon supply voltage only, no? That means as we change the voltage, automatically what happens, as we increase the voltage, the rate of flow of electrons will be moving very fast, yes or no? So likewise we can say that, very simple statement it is, V is directly proportional to I. As we increase the voltage, automatically current also increases, because the supply of as the potential difference is increasing, means the rate of flow will be increasing. So directly we can say that V is directly proportional to I. When you remove the proportionality constant, that means the directly proportional is there, when you remove it, you will have the proportionality constant as R. That means whatever the conductor we have taken, that conductor is abbreviated as R. Okay, so V is equal to I into R, which is very very important. If we don't know this formula, so you are not going to get any electrical subject also. So this is basic. If you know this, you can do the numericals based on by using this formula. Okay, B is equal to IR. So what about I? From that relation we can write I is equal to V by R. So you can see that Ohm's law triangle, we can write it in the Ohm's law triangle. On that Ohm's law triangle, you can observe that the triangle is there. If you place the thumb on the V, if you place thumb on V, you just place thumb on V, all of you, you can observe that in the denominator it is I and R are placed. That means I into R. So you can take that IR. If you place thumb on I, if you place thumb on I, what you can observe, it is showing like numerator by denominator, that is V by R. We can write, that means Ohm's law triangle. From that one we can write any value. Suppose if you want to know the value of R, if you want to write R is equal to how it is looking, it is V by I. Likewise we can get the value of any parameter. If you know two values, you can get the unknown value from that one, from Ohm's law triangle. Okay, so that is the graph we can see. Just now we discussed, no, as the we can see the graph as the directly proportional, V is directly proportional to current, means it is obeying Ohm's law. That means as the voltage increases, current also, voltage value, voltage is on x-axis, current is on y-axis. So I am increasing from 0 to infinite position. You can observe the current also, you can get the value in increasing position. Okay, so you can observe the slope that is passing through origin, from it is starting, as the voltage is 0, current is also 0. As the voltage increases, the value of magnitude of current is also increases. So then only we can say that, it is obeying Ohm's law. Suppose if the graph is not like that, so can observe that for the diodes the same thing will not happen, the graph is different. Okay, why it is different, you know? Okay, because it initially it is does not allowing, we know that semiconductors is behaving like insulators sometime, no? So it is not allowing after the breakdown of, because two or more materials are doped, no? So what happens is, when they are doped, what happens, automatically there is a depletion layer between that one, p type and n type material, there is a depletion layer. So in order to break that, depletion layer, then only some extra voltage must be given. So for small amount of voltage it is not going to break. So that purpose, what happens is, we have to keep on increase the voltage, then whatever the depletion layer is there between p type and n type material, then the depletion layer will going to break, then the allow of electrons will be possible, then it will become like a conductor. So that means we can observe that, we will get that the graph is not constant, that means not increasing. So it will be, okay, it is not constant, it will be after some cutting voltage it starts conducting. So that is why for diodes it is not applicable. So that's why we have some limitations. So limitations are like this, it is applicable only for conductors and not applicable for some following cases like semiconductors. Just now I have taken the example as semiconductors. Semiconductors means the graph will be like this. Okay. 1 minute. So it is not like passing through origin. Is it clear? So it will be like this. After some cut-in voltage, the graph will be like this. Okay, this is V and this is I. So this is the graph for semiconductors. So we can say that it is as here we can observe that voltage is 0 means current is 0, but here voltage is some value is suppose 0.2. Suppose 0.2 is there. Is the current is there? Current is also at 0. But current is not increasing. As voltage is increasing, current is not increasing. So which is not allowing. So it does not. So Ohm's law is not applicable for semiconductor. So we cannot give that V is equal to I into R. So this is not valid for semiconductors. So that is why not applicable for semiconductors and not applicable for metals which are heated up. So what happens when they are heated up? Suppose if the metals are heated, what happens? The heat will be more, no? So that's the heat will be more means automatically temperature is increased. So already we said in the statement it is a constant temperature. So it is not applicable. And also we can see that electrolytes. What is the electrolytes? Here when we take the electrolytes, that means any solution if we take, automatically what happens is enormous gases are released at the electrodes. Automatically enormous gases are released means automatically the temperature is changed. As the temperature changes, what happens? Automatically it is not applicable. Temperature changes means as the voltage is increases means current is increasing rapidly. Okay, current increases rapidly. So it is not following the as the voltage increase means current increasing. Meanwhile, it is producing so much of current. So it is, that's why it is not applicable. And also gas filled tubes. So the same scenario will happen for it. Okay, is it clear all of you? Shall we will start the Kirchhoff line next class. It will be okay because it will take much time to complete that KCL and KVL. So you can unmute yourself and you can ask any questions related to it. Is it everything okay, all of you till now? Today we have discussed about what are the different
Yes, sir.
classification of materials we have
Yes, sir.
taken.
Sir,
Okay, we have seen the classification of. Yeah, ask me. We have seen the classification of materials. We have seen types of elements, that is active and passive elements. Also we have seen the definition for voltage. Voltage definition is nothing but potential difference. We can call voltage or potential difference or electromotive force. All are giving the same thing. Okay, all are giving the same thing. Okay, and also we have seen definition of charge. Charge is nothing but the total addition of excess electrons into the atom. What happens? It will become some charge. Okay, it will become some charge, that is negative charge. Addition of electrons to it means it will become negative charge. Addition of protons means it will become positive charge. That is the thing we have seen. And also we have seen the Ohm's law. Okay, so this is the things today we have discussed. Tomorrow we will go with the Kirchhoff's voltage law, Kirchhoff's current law, like that. Okay, I will share you the notes in the after completion of some 50% of this unit. I will share you the notes. Okay, you
Sir,
can
we need
take the
type
screenshots wherever
notes.
you want. Sorry, your voice is not clear. Maybe the time is